Welcome back again. This time I want us to do a question based on graphs, especially the velocity time graph. So let's read and try to answer questions. They say a stone was thrown upwards with a velocity of 15 meters per second from a 30-meter building. So we are on a 30-meter building. We throw a stone. When we throw the stone, it will go upwards, reach a maximum height, return to where it was thrown, and return to the ground. This is what is happening here. And study the velocity time graph below and answer the question that follows. So we are given a velocity time graph here. We are given initial velocity, time taken to reach maximum height, time taken to return to where it was thrown, and the total time for the entire motion from where it was thrown to where it returned and to where it hits the ground. So this is the total time for the entire motion. So number one, they say write down there. They didn't say calculate, they said write down there. So you just have to look at this and write down what they are asking you here. So they say write down the time taken for the stone to reach its maximum height. Of course, it's 1.53 seconds. You can write, let me write with a different pen. 1.53 seconds. So here you see 1.53 seconds. Do not forget the units. Don't just write 1.53. Write 1.53 seconds. So write down the time taken to return to where it was thrown. The time taken to where it was thrown. So it's 3.06 seconds. It takes 3.06 seconds to return to where it was thrown. Write down the total time for the entire motion. So the total time for the entire motion is 4.44 seconds. 4.44 seconds. We can see it here. And then write down the velocity with which the stone hits the ground with. That means the final velocity, which is negative 28.51. And this graph is not drawn to scale. Don't mind when the numbers do not match. It is not drawn to scale. And meters per second. So it's negative 28.51 meters per second. Let's go to the second phase of the question. They say calculate this is where we have to calculate now, the maximum height reached by the stone above the ground. So they want the height from the ground to its maximum height. It will be around here. They don't want the height from here to here. So they want the total height, the maximum height rather, not the total height, the maximum height. Let's calculate it here. So we are gonna the maximum height. So I want us to use the area to calculate. So when we use the area, it will give us the height from here. Okay, when we calculate the area, it will give us a height from here to here. So after we get that height, we add it to this 30 meter there, then it gives us the maximum height. So let's do that. We say that the area, okay, the area is equals to half base times height. We say the area is equals to half change in time times change in velocity. Forgive me for that, velocity. So what is the area? Is equals to half change in time. So it's 1.53 seconds. It's from here to here. So it's 1.53 times the change in velocity, which is 15. It's from 0 to 15, so it's 50. Oosh. Let me take another pen. So it's 15. So our area is, let me take a calculator. So it's half into 1.53 times 15. It gives me 11,48. It gives me 11,48. 11,48 meters. So have we answered the question? Of course not yet. So it wants the maximum height, so we add our height here, which is 30. So the height is equals to 30 rather, let me say 30 plus 11,48. So our total height is, I believe it's 41,48 meters. Therefore, we answered the question. So let's move on to the last question. This is how easy the motion of graphs are, or the graphs of motion rather. So the last question, time taken for the stone to fall 30 meters. So we want the time it takes to fall from this, from here to here. So we know that the velocity of here is minus 15. The velocity of here is minus 28. We're given there. And the height we're given, though, so we can use this equation of motion to calculate for time. There are two equations that we can use, but I don't like using the quadratic formula one. So let's use this here. Vf plus Vi over 2 times the change in time. So we have 30. But because they choose upwards as positive, so it's going to be minus 30 is equals to, how did they know that they chose upwards as positive? Because when the stone is going upwards, its velocity decreases, and when it comes back, it starts to increase in the negative direction. So that's how I knew they chose upwards as positive. So let's finish here. So our final velocity is negative 28,51 plus positive 50 over 2. Sorry about that, times changing time. So let's find the value of here and then divide it to 30. Let me say negative 28,51 plus 50 over 2. I get a value of negative 6,755. So I'm gonna say negative 30 divided by answer, and I get a value of 4,44 seconds. I get a value of 4,44 seconds. So the change in time is equals to 4,44 seconds. So I think we are done with this question, and you can see how easy it is to answer these questions here. It's very, very easy. So it says calculate the time taken for the stone to fall 30 meters. Yes, we answered it. So it's 4,44 seconds. And yeah, let's wrap this up, and when we meet again, we will talk about the position